Welcome back, everyone. Houston Math Prep here. We're going to introduce to you what the natural exponential function is. We're going to do an explanation based on compound interest, which was our last video in this series. So I've got my compound interest formula here. If you're not an expert at compound interest, that's okay. You can still probably follow along with this one, no problem. Let's say we deposit $1. That's going to be our principal. And let's say we have an annual rate of 100%. And we want to compound interest a few different ways and just see what happens. So let's explore what the ending balance is after 1 year. So t would be 1 in our formula if we compounded annually. Well, if we compound annually, then that means we are compounding once per year. So our n is going to be 1 in the formula, and this is our 100% as a decimal. So if I plug in this information and I compound annually, then I get this formula, and after 1 year, I get an amount of exactly $2. If I look at the next one, which is compounding quarterly, that means I'm going to compound the same interest rate but 4 times in 1 year. So we'll break up our interest rate into 4 pieces and use it 4 times. Compounding quarterly gives us actually $2.44. So we get a sizable increase compounding quarterly versus compounding annually. If we look at compounding monthly, which would be 12 times per year, then we plug in 12 in for n in our formula, and we get that our compound interest helps the balance accumulate to $2.61 at the end of a year. So you might see a pattern here. You can tell the more often that we compound, the more interest we're getting. The more times we compound per year, the more interest we will get from the compound interest in total. So let's bump it up a bit, more often than monthly. And let's say we compound our interest daily. So we'll use 365 times. If we do that, then our n becomes 365 here, and we actually get $2.71 at the end of a year. Let's say we wanted to see if we could get even more money than that. How could we get more money? Maybe we compound, say, 1,000,000 times per year, right? So we compound 1,000,000 times per year. We put in 1,000,000 for n in our formula. So it looks something like that. But it turns out if I round to 2 places, I just get $2.72. 1,000,000 is a whole lot more than 365 times per year, but we're only getting just a little bit more out of it. In fact, to get this 2.72, this $2.72, we had to actually round up. If you put this in the calculator, you'll see you had to round up to get that extra penny. So then our final question of this experiment is, how could I get the most money possible? What should I do? Well, I should just plug in the biggest number that I could possibly write down or imagine or think of that I could put in the calculator, right? No matter how large of a number I write down, I can always just add more digits to the end. So we think about what happens if we were using the biggest number we can think of, maybe something like infinity. Infinity is not a real number. It's not something that we can just plug into formulas and get an answer to. But if we take bigger and bigger values for n and just keep letting this number for n blow up bigger and bigger, then the biggest number we can get without rounding up is going to be a number that's about 2.71828 and some change. And this decimal is going to keep going on forever. This number here is a very, very special number in math. It has its own name because it's so common. We have some other numbers that we use all the time in math, and they're super famous, like pi, right? Pi is about 3.14 and some change as well. So this number, we give it its own name. We use it all the time in math. This is called the natural exponential. We call it e. So pi is about 3.14 and some change. E is about 2.71 and some change. That's called the natural exponential. It's a super common number that you'll see in math all the time. It's not a variable. It's an actual number when we see that. And if we make an equation that looks like y equals e to the x, like y equals 2 to the x or y equals 5 to the x, this is an exponential function, but now it's called the natural exponential function because we have the natural exponential as its base, e to the x with e as a base. This natural exponential function has applications all over many branches of science and mathematics, lots of places where we're trying to compute and model things. These are just some of the applications that you'll see the natural exponential function used for. Okay, that's our very brief intro to the natural exponential function and the constant e and where it comes from. Thanks for watching, everybody. We'll see you in the next video.